Okay, this is Integrated Math 2. We are in section 3-7 and we are on page 177. So we're going to do problem 4. It says separating overlapping triangles. All right, so we're given this figure and we're given the information that angle CAD is congruent to angle EAD. And we're also given that angle C is congruent to angle E. And we're asked to prove that line BD is congruent to FD. All right, so the first thing I'm going to do is I'm going to mark the figures that are congruent. So I know that those two angles are congruent, and I know that these two angles are congruent. So I need to prove that these two lines, that's this line and this line. So I need to look for a triangle where those two lines are in them. And what I see is these little triangles here. I'm going to redraw that triangle. So I have triangle BCD, and I have triangle DEF. And this is what we're actually going after to prove that those two lines are congruent. All we're given, though, is that this angle and this angle are also congruent. That doesn't give us a whole lot to work with. Well, what else do we know? Well, when we look at angle D, we see there are two lines that cross right there. So we know that these angles on opposite sides, those are going to be vertical angles. So I know that those two are also congruent. So that gives me two angles and no sides. That's a problem. What we're going to have to do is we're going to have to back up and use more of this figure. We'd like to have this side here be useful to us because angle side angle is something that we can use. So what's a triangle that has this side and this side? Well, we can look at this big triangle out here. Again, I'm going to redraw that big triangle. Part of this is separating those overlapping triangles, is redrawing those triangles so that you're better able to see what we're looking at. All right, my triangles aren't perfect, but I have angle A and angle A right there. Those are both sides of angle A. This is C, and this is D. This is also D, and that's E. All right, well, that's a lot of useful information, right? Again, they're slightly off-center than I had before, but there's a lot of stuff we know here. So let's start writing what we know. So angle CAD is congruent to angle EAD. That's this angle, and that's given. We also know that angle C is congruent to angle E. That's this angle, and that's given. What else do we know? Well, line AD and line AD are congruent. Why are they congruent? Because of the reflective property of congruency. So that gives us two angles and a side. So we can say that triangle ACD is congruent to triangle AED by, so I'm going to mark that just so you know, angle, side. Angle, side, or side, angle. And that's one of our proofs. So now that we know that, now we can say that CD is congruent to ED because of congruent parts of congruent figures. If we know that congruent parts of congruent figures, well, let's go back here. We see those two are congruent. That means that we can prove that triangle, I'm going to make this a little one, FED is congruent to triangle, let's see, BCD. And we just used angle, side, angle. Right? So if we know those two parts are congruent, the thing that we were asked to prove is these two lines here. Well, now we know that BD is congruent to FD, form congruent parts of congruent figures.